Hey guys, welcome back to Easy Ass Engineering. In this video, I want to show you probably the hardest, and I say hardest in quotations, problems in engineering economics, which is finding the IRR. Honestly, it's pretty easy, but it is the most difficult thing in this course. So this is a pretty good example, and it's asking us to find the IRR at A. So basically the interest at A, company A. There you go. So the General Hospital is evaluating new office equipment offered by 4 companies. The useful life of the equipment is 4 years. So let's go ahead and write our knowns from the initial problem. We have 4 years is the life, and we're working with company A. So these are the values. So in these types of problems, you're going to want to stick to one time zone, one time frame, which is we're going to keep, I like to be in the present worth, and that's where we're going to find the present worth of all these cash flows. So if you're looking at company A, the present worth of the first cost is the initial cost. It's negative and it stays in, it's already in the present, so you don't need to add any compounding factor. Maintenance and operating costs, 1600 annual. You're going to have to put that in there. The compound interest factor. So negative 1600 because it's a payment, and we're going to use the present to annual. So we're finding P given A, I, and 4 years. And the annual benefit is a positive 8,000 every year. Bring it to the present, PA, I, 4. And the salvage value 3,000. It's in the future, you got to bring it to the present, so we're going to use PFI4. Sorry guys about that, sucks, but I'll rewrite it better soon. So these two over here, you can combine them in, sorry about that too. These two over here can be combined into one. You just subtract them, and this is like common in both of them, so you can keep it like that. So I'll rewrite this cleaner for you guys. Present worth is equal to negative 15,000 negative. So plus, and now we'll do 8,000 minus 1600 with the common factor of P over A, I, 4 out, plus 3,000 P, F, I, and this is IRR. That's what we're going to have to find. So guys, this is net present worth. So the actual IRR is found when the net present worth is 0. Always remember that. So I gotta make this net NPW equal to 0. So I'll rewrite this negative 15,000, and this becomes 6,400 P by A, I 4 plus 3,000 P F IRR 4, and this is also IRR. Don't forget. So now that we have this, we can bring this over, and it looks like this. So IRR problems are usually done using trial and error when you're doing them on paper. You can use Excel, there's an IRR function, but on exams you'll typically get them like this. So you got to make both sides equal. So if I plug in random values of IRRs, I can see if this side will equal to 15,000 with that IRR that I chose. So let's go ahead and choose, let's start with 10%. Alright, we're going to try to make that right side equal to 15,000. So if we go with 10%, let's go in yellow over here. We're going to have to use the compounding tables. So what ends up happening is 15,000 So we chose 10%, so we're going to have to go to those compounding tables, which you can find in the back of any textbook, economics textbook, or Google them. So I'm going to go up to the tables where it says 10% and grab the P over A, that whole bracket value where n equals 4, and that's 3.170. 3.17. And the other one is the P over F compounding factor. At year 4, 10% is 0.6830, 0.6830. And that right side, if it's equal to 15,000, we can stop right there, but that's not going to happen. 6,400 times 3.170 plus 3,000 times 0.6830. So that gives you 22,337. So we're too high. We know that 10% is no good. So let's move on to 20%. Why does it always do that? It's annoying. 20%. And again, so the compounding factor for 20% at n equals 4, P over A is 2.589 plus 3,000. And for P over F, the compounding factor at year 4 is 0.4823. So 589, adding those together, 18,016.5. So we're getting closer. So I guess, so you can see that our percentage, the higher we go, the closer we're going to get. Now let's just move on to the 30%. Let's just skip another. We could skip 5s, but let's just go for 30 because we're going to end up interpolating anyways. That's what these problems end up. That's what ends up happening in these problems. We end up interpolating. All right. Let's just go to the tables for 30%. P over A at 4 is 2.166. 3,000 for P over F at 4 years is 0.3501. Ends up giving us a value of 3501. 14,912.7. All right, so we crossed. Oops, sorry about that. Can we write it? 14,912.7. All right, you see that we, from the jump from 20% to 30%, we crossed 15,000. It's somewhere in there. So we're gonna have to interpolate. Now the way I remember interpolating is basically y that you're looking for over what you already have, y1, x that you're looking for minus x1 is equal to y2 minus y1 over x2 minus x1. So what is our values that we have already? We have y1, x1, x2, y2, right? So x1 equals 20%. We're interpolating between 20 and 30. Y1 is its value of 18,016.5. X2 equals 30%, and its value is 14,912.7. Setting this up, guys, the y over here, we already have it. It's 15,000. That's where we're looking. That's where we're looking to find its corresponding x value. So y1 is 18,016.5. X is what we're looking for, the percentage value, minus x1, 20%, is equal to y2 minus y1, 14,912.7 minus 18,016.5 over x2 minus x1, which is 30 minus 20, 10%. Guys, so when you cross multiply and you solve for x, you end up getting 29.7%. That is your IRR for the problem. It's a lot of work, but it's really simple, guys. It's typically going to ask you to find the IRR for several different schemes, and you pick the best one, or they're going to give you a MARR as well, so you're going to have to compare with the MARR. Alright guys, thanks for watching. If you enjoyed the video, leave a comment down below and subscribe and like, and tell me if you have any questions on this. I'll answer you, no problem. See you in the next video.